Introduction to CASB. Have you ever attended a cloud security meeting where someone said, "We already have SASE, so why do we need CASB?" Or maybe you've heard another engineer say, CASB and SASE are basically the same thing. These are some of the most common misconceptions in enterprise networking today. If you're preparing for interviews, designing enterprise security architectures, or deploying cloud security solutions, understanding the difference between CASB and SASE is essential. And here's the good news. By the end of this video, you'll not only understand what CASB is, but you'll also know exactly where it fits in a modern SASE architecture, why enterprises invest millions in CASB solutions, and how it protects sensitive data in cloud applications. This isn't just a theoretical topic. It's something you'll encounter in real-world enterprise environments using platforms like Microsoft 365, Google Workspace, Salesforce, ServiceNow, Box, Dropbox, AWS, Azure, Slack, Zoom. So today, we're going to break this topic down step by step, using simple language, practical analogies, and real enterprise scenarios. Let's begin. Today's agenda. Here's what we'll cover in this complete guide. First, we'll understand the cloud security problem that led to the creation of CASB. Then we'll answer an important question. What exactly is CASB? Next, we'll explore why organizations need CASB and the challenges it solves. In the next parts of this series, we'll dive deeper into how CASB works internally, CASB architecture, inline and API deployment models, CASB versus SWG, CASB versus ZTNA, CASB versus firewall, CASB inside a SASE architecture, enterprise deployment examples, troubleshooting, best practices, and interview questions. So let's begin with the problem. Because before understanding the solution, we first need to understand the problem. The evolution of enterprise networks. Let's travel back about 15 years. Most organizations had a very simple network architecture. Everything was inside the company. Applications were installed in the corporate data center. Employees worked from the office. File servers were on-premises. Email servers were on-premises. Databases were on-premises. Users connected through the corporate LAN. Remote employees used VPN. Life was simple. From a security perspective, everything was inside a well-defined perimeter. Think of it like a castle surrounded by high walls. Everyone worked inside the castle. Security teams only had to protect the gates. Traditional firewalls performed this job very well. They controlled source IP, destination IP, ports, protocols. Everything entering or leaving the corporate network passed through the firewall. This security model worked perfectly until cloud computing changed everything. The cloud revolution. Now let's look at today's enterprise. Employees no longer work only from headquarters. Some work from home. Some work while traveling. Some connect from customer locations. Some work from different countries. At the same time, applications have also moved. Instead of living inside the data center, applications now live in the cloud. For example, the HR department uses Workday. Finance uses Salesforce. Engineering teams use GitHub. Employees store documents in Microsoft OneDrive. Marketing teams collaborate using Google Workspace. Project teams communicate through Slack and Microsoft Teams. Developers deploy workloads in AWS and Azure. So now, instead of accessing one corporate data center, users access hundreds of cloud applications every day. This creates an entirely new security challenge. Because the traditional network perimeter no longer exists. Instead of one castle, imagine hundreds of buildings spread across the world. Each building stores valuable company information. Each building has different security requirements. Each building is accessed by different employees. Managing security suddenly becomes much more complicated. The problem with traditional firewalls. Let's understand this using a practical example. Imagine an employee named Alice. Alice works in the finance department. She's preparing next quarter's financial report. The report contains revenue forecasts, profit margins, employee salaries, customer information, acquisition plans, highly confidential business data. Now suppose Alice decides to upload this file into her personal Dropbox account so she can work from home later. From the firewall's perspective, what does it see? It sees encrypted HTTPS traffic going to Dropbox. That's all. It cannot determine which file is being uploaded. whether the file contains confidential information, whether the Dropbox account belongs to the company or to Alice personally, whether this upload violates company policy, whether customer data is leaving the organization. The firewall simply allows HTTPS traffic. Mission accomplished. But from the security team's perspective, this is a serious problem. Sensitive corporate information has now left the organization without anyone noticing. And this is called data leakage. This is exactly the type of challenge that traditional firewalls were never designed to solve. Understanding shadow IT. Now let's discuss another major challenge. Shadow IT. This term appears frequently in enterprise security discussions and interviews. So what does it mean? Shadow IT refers to technology services, applications, or cloud platforms that employees use without approval from the IT department. Let's consider another example. A design team needs to share large files with an external customer. The corporate-approved platform is Microsoft OneDrive, but an employee feels Dropbox is easier to use. So they create a free Dropbox account. No approval, no security review, no compliance validation, no encryption verification, no monitoring. Within weeks, several employees start using the same platform. Soon, hundreds of confidential files are stored outside the organization's approved environment. The IT department has absolutely no visibility into this activity. They don't know which users are using Dropbox, what files have been uploaded, whether sensitive customer information is exposed, whether someone has publicly shared confidential documents. This uncontrolled use of cloud applications is known as shadow IT. According to industry research, many enterprises use hundreds or even thousands of software as a service applications, while IT departments are often aware of only a fraction of them. Without visibility, security teams cannot protect what they cannot see. Introducing CASB. So now we understand the problem. Cloud applications are everywhere. Employees work from anywhere. Sensitive data moves constantly. Traditional security tools cannot provide complete visibility. This is where CASB enters the picture. CASB stands for Cloud Access Security Broker. Let's simplify that name. The word broker simply means an intermediary, someone who sits between two parties. Think about a real estate broker. The broker stands between the buyer and the seller. Or think about airport security. Every passenger passes through a security checkpoint before boarding an aircraft. The security officers inspect passengers, verify identities, scan luggage, detect prohibited items, allow safe passengers, stop dangerous activities. CASB performs a very similar function, but instead of inspecting passengers, it inspects cloud access. Instead of checking luggage, it examines files. Instead of verifying boarding passes, it verifies user identities. Instead of securing an airport, it secures cloud applications. In simple terms, a CASB sits between users and cloud services, applying security policies before sensitive data reaches the cloud. It becomes the intelligent security layer that understands who is accessing the application, which application is being used, what action the user is performing, what type of data is involved, whether the action complies with company policy. Only then does it decide whether to allow, block, encrypt, quarantine, or monitor the activity. This level of visibility is something traditional firewalls were never designed to provide. Why was CASB invented? Now let's answer the next logical question. Why did the industry create CASB? The answer is simple. Because enterprises needed security that understood cloud applications, not just network traffic. CASB was designed to solve 4 fundamental business problems. 1. Visibility. Organizations need to know which cloud applications employees are using. Without visibility, there can be no control. 2. Data protection. Sensitive information such as customer records, financial reports, intellectual property, and healthcare data must not leave the organization without authorization. CASB can inspect content and enforce data loss prevention (DLP) policies. 3. Threat protection. Attackers often use stolen credentials to access SaaS applications. CASB helps detect unusual behavior such as impossible travel, risky logins, abnormal downloads, or mass file sharing. 4. Compliance. Many industries must comply with regulations such as GDPR, HIPAA, PCI DSS, and ISO 27001. CASB helps enforce security policies consistently across cloud applications and provides audit visibility for compliance teams. Now that we've built a strong foundation, we understand why traditional security models are no longer enough, how cloud computing changed enterprise security, what shadow IT is, what CSB is, why organizations need CSB. In Part 2, we'll go much deeper into the technical side by exploring how CSB works step by step, the complete CSB architecture, traffic flow explained, inline proxy versus API-based CASB, identity integration, policy evaluation process, enterprise packet flow, and request lifecycle. From this point onward, you'll begin to see exactly how CSB operates behind the scenes in a real enterprise environment. If this video helped you understand the difference between CSB and SASE, please give it a thumbs up and share it with your colleagues. If there is a specific topic you'd like to see next, let me know in the comments. Thank you for watching. Thank you for learning with SASE Cloud Networking, and I'll see you in the Part 2 of CSB Complete Guide for Beginners and Engineers.